What would you say if you could gain superhuman speed just by putting on a jacket? What if this simple act would allow you to do things 10 or even 100 times faster than normal? Well, this is the effect that supermirrors can have on our neutron instruments at ISIS. Supermirrors are flat sheets that are capable of reflecting neutrons, much like normal household mirrors reflect light. These supermirrors can be used to line the insides of our neutron instruments, specifically the part between the neutron source and the sample of material you are trying to measure, and they reflect the neutrons that would otherwise fly off and be lost, directing them instead down the instrument and towards the sample. These sheets of supermirrors can be assembled in a multitude of arrangements, and there is no standard design that is perfect for all instruments. Instead, engineers like myself have to simulate and analyse a number of different configurations and work out which one is the optimal one for each individual instrument. There are a variety of parameters to consider, including the number of mirrors to use, how reflective they are, their size, and their shape relative to one another. As well as trying to increase the number of neutrons hitting the sample, it is also important in supermirror design to make sure the other qualities of the instrument are not affected detrimentally. For example, an instrument with no supermirror will have a neutron beam with a constant cross-section, but supermirrors can sometimes reflect neutrons in such a way that the neutron beam will have bright and dark spots rather than a constant brightness, which means the data you get from your sample may be inaccurate. The supermirrors must therefore be designed in such a way that avoids this effect, increasing the neutrons hitting the sample without potentially ruining the results. But why does this matter? Why does it help us to reflect neutrons rather than let them continue on their natural course? Well, the answer is that it saves us time. The more neutrons can be directed at the sample, the more data points we can collect in a certain time frame. And given that supermirrors can provide 10 to 100 times as many neutrons through the sample point as the instrument might have on its own, this means that installing supermirrors can reduce the time needed for an experiment from several days to only a matter of hours, saving time, resources, and ultimately money. With the ability to reduce the time and cost of neutron experiments, it is in this way that supermirrors can give superpowers to our neutron instruments.